In this video, we're going to solve for the time variable in compound interest formulas. We'll do one problem with monthly compounding and another problem with continuous compounding. In the first problem, 5% interest is earned on an investment of $1,000 where interest is compounded monthly. How long will it take for the money to double? The first thing we have to do is write the formula for compounded interest. And the formula here is A equals P times 1 plus R over N raised to the NT, where P is the principal, in this case 1,000. R is the interest rate as a decimal, so we write 0.05 instead of 5%. And N is the number of compounding periods in a year. In this case, monthly means N is 12. And A is our amount after time T. Here we're wanting to find out how long for the money to double. So it's going to double to 2,000, so we let A equal 2,000. We plug all those values in, and what we get is 2,000 equals 1,000 times 1 plus 0.05 over 12 raised to the 12t. This is an exponential equation, and our exponential term is this big quantity in parentheses raised to the 12t power. Remember that when you have a variable that's an exponent, that's an exponential expression, and we have that in that quantity. So now we want to get that quantity by itself. We do so by dividing both sides by 1,000. This gives us 2 equals the quantity 1 plus 0.05 over 12 raised to the 12t. Now we want to solve this equation, and the way we do that is to log both sides so 12t is no longer an exponent. We can use any base we want. I'm going to use the natural log. I take ln of 2 equals ln of that quantity. And by the exponent property of logs, we can move that exponent of 12t out front. So we get ln of 2, which is just a number, equals 12 times t times ln of this quantity. And ln of the quantity is just another number. So really what we have is a number equals t times a couple of other numbers. It's really a simple equation now. We divide both sides by 12. We divide both sides by that quantity ln of 1 plus 0.05 over 12. We get the result ln of 2 over 12 times ln of that quantity equals t. Now we just have to evaluate that expression to get the value of t. Now here's a really nice easy way to do this. If you don't have a calculator on hand, I use the Google search bar or the Google search window that I have on my computer, and I enter it in just as I have shown here, ln of 2 in parentheses divided by the quantity 12 times ln of 1 plus 0.05 divided by 12. You have to make sure and get your parentheses correct. You notice I have 2 right parentheses on the far right. And when I put in that equal sign, I get my answer showing up, 13.8918047. And rounded off, that's 13.89. And just to check, is this really giving me the right answer? I plug in 1,000 for P, and I have 1,000 times 1 plus 0.05 divided by 12 raised to the 13.89 times 12 power. You notice I have all the correct parentheses, and I get a result $1,999.82 if you round it, which is telling me I did get the right answer. There's a little variation because I rounded off my answer. In the next example, I have if 4% interest is compounded continuously, how long will it take for your money to triple? And that's all I give you, and it seems like, well, there's not enough information. Well, there actually is. Here we use the formula A equals P times e to the RT power because this is continuous compounding. And in this case, when we triple our money, A equals 3P. And we use R as 0.04 representing 4%. So we plug those values in. And when we plug them in, we get 3P equals P times e to the 0.04t. Seems like we have too many unknowns here, but if you divide both sides by P, the P's cancel out and you're left with 3 equals e to the 0.04t. Now we can solve this by taking natural log of both sides, and this gives us ln of 3 equals ln of e to the 0.04t power. Using our exponent rule, we move the exponent out front, So we get ln of 3 equals 0.04t times ln of e. ln of e once again turns into 1. So we have ln of 3 equals 0.04t. We just divide both sides by 0.04. So our answer is t equals ln of 3 divided by 0.04. So we get 27.47 years if you round it off. And I've checked this using that Google calculator again. I used p equal 1,000 and I used 0.04 for r and that 27.47 answer for t. And when I calculated it out, I got 3,000.56, which is very close to 3,000. So our answer is correct. The variation is again due to rounding. And I just picked any value here. I picked p equal 1,000. I could have picked p equal 100 and then we'd get 300 for the total amount, just to put some value in there to check this.